All right, so for section 4.1, we're going to discuss radian and degree measures. So this is kind of our intro to trig topic here. All right, and so when I talk about radians and degrees, all I'm really talking about is angles. Okay, and so we're just going to take an angle. Let's say we have a ray that does this, and then we're going to say we're going to open this up to another ray of equal length, so it'll be a little bit longer like that. All right, so the side that we started with is referred to as the initial side. Yeah, so that is the initial side. Then the side that we open to is called the terminal side. Okay. And then the angle, of course, is created by shifting that up, and we call that theta. Okay, so we have an initial side, a terminal side, and then we have the angle theta. Okay, and then of course the corner is referred to as the vertex. Okay, all right, so I know that doesn't look the best in my drawing, but I'll explain further in just a second. So the starting position is the initial side, so it's kind of where we started at. Okay. Then after the rotation, so we make some kind of rotation to it. So after the rotation, that is called the terminal side now. All right. And then depending on which angle that which way we move the angle, we could say that if it moves in a counterclockwise position, so think of a clock, so then it would be moving like a circle to the left. So if it is in the counterclockwise position, then, or moving in the counterclockwise direction, then the angle is positive. So we have a positive angle. Okay. And then if the angle is moving in the clockwise position, so thinking of a circle to our right, or moving in the clockwise direction, then that angle would be negative. So we have a negative angle. Okay. All right. So that is that's discussing the initial, terminal, and all that stuff. Okay. So an angle is also said to be in the standard position if it has its vertex at the origin, and let me try to make this. Well, there we go. And the initial side is on the x-axis. Okay, so we have the initial side here, and it is on the x-axis, and it's the positive x-axis. Okay, so this angle, no matter what the terminal side is, will always be said to be in the standard position. Okay, so that angle is in the standard position. Okay. All right, so the other thing that we want to discuss are coterminal angles. So coterminal angles, they share initial and terminal sides. Okay, well, you may be thinking, how does that happen? If angles are made up of initial and terminal sides. So here is what that would look like. Okay, so we have an angle of some kind. Let's say it's right. Well, let me try to draw that a little bigger and better for us here. Okay, so let's say that we have this, and we have an angle that we'll say, here's the initial side, here's the terminal side. Okay, so we've got an angle moving this way that we'll call alpha. Well, because I can rotate in a counterclockwise and clockwise direction, I can also rotate this way and call this angle beta. And so those angles would be coterminal because they share the same sides, even though the angles are going in different directions. Okay? And so now I want to talk about radians. So definition of radian. And radian is something that you probably heard in like a high school geometry class, or like math, would be math 2 maybe. All right, so the definition of a radian, it is the measure of a central angle that intercepts an arc equal in length to the radius of the circle. Okay. So, what does that mean? Okay. So we have a circle, but I'm going to draw it on a coordinate grid here. So we have this circle, okay, and it has a radius of this far, right? So it has a radius of r. Well, then up here, it also has a radius of r. And here is theta. All right. Well, if this length from here to here is r, so we're going to say that's equal to r, then theta is 1 radian. Okay. So radian is just a measure of angles that is saying how far did I have to move to the left or right, or open the angle, for the portion of the circle to be equal to the radius. Okay, so that's what deems a radian. But we will use radians throughout the course, but we'll use it in more of a numerical sense and not so much a graphing or a theoretical sense. Okay, all right. And so the last thing here that I want to talk about as far as pairs of angles is the concept of complementary and supplementary. Okay, so complementary and supplementary angles. Did I spell that? No, I spelled this. There we go. Oh, even nicer. All right. So complementary and supplementary angles. All right. So for a angle to be complementary, how you would normally think of that would be angle 1 plus angle 2 is equal to 90 degrees. Okay. For supplementary, you would think angle 1 plus angle 2 is equal to 180 degrees. Okay. Well, in trig, we don't really use 90 and 180 degrees to say this because we want to talk about it in radians. All right, so we have angle alpha plus angle beta is equal to pi over 2 radians. Okay, always will be pi over 2 for 90 degrees. For supplementary, alpha plus beta is equal to 180 degrees, or pi. Okay, so it's pi radians. So we have degrees and radians both to use to describe angles now. But let me show you where that comes from in our coordinate system. Okay. So we have this coordinate system. Okay, well, if 0 degrees is here, then to move positive, I always move counterclockwise, then 90 degrees would be here, 270 degrees here. Nope, excuse me, 180 degrees, not 270. Getting ahead of myself. 180 degrees would be here. 270 degrees would be here. And then 360 degrees would get us back full circle, so to speak. Okay, well, from a radian standpoint, this is 0 radians. This is pi over 2 radian. This is pi radian. And this is 3 pi over 2 radians. Okay, and then would go all the way back to 2 pi to go full circle. Okay, so think about it that, pi is half of the circle, so pi is supplementary. Okay, and then complementary would be a fourth of the circle, or 90 degrees, which is pi over 2. All right, now this coordinate grid is broken up into what we call quadrants, and so the portions, the corners, those are deemed to be quadrants. All right, and so we always start with the top right and go in a counterclockwise position. So if a point lies in this quadrant, the top right, then it is in quadrant 1. Then I go on around and keep moving in a positive manner. So quadrant 2, quadrant 3, and quadrant 4. Okay. So if you are asked if a point lies in quadrant 1, 2, 3, or 4, then you would just have to look at the point on the coordinate plane, see where it lies, in coordinates to the origin, and that will tell you which quadrant it is in. Okay. So now that we're talking about degrees some and not just radians, let's kind of talk about that for a second. So let's talk about degree measures. All right. So as you can see from our quadrant or coordinate plane here, 360 degrees is equal to 2 pi radians. Okay. And then 180 degrees is equal to pi radians. Okay. And so these numbers aren't just, they didn't just make these up out of thin air, but we can use these, and knowing this, to be able to convert from degrees to radians and radians to degrees. Okay, so let me show you how to do that. So from a conversions standpoint, conversions, all right, so to convert degrees to radians, we take the degrees, whatever we're given, and we multiply it by pi, that's in radians now. So this gets us to radians, divided by 180 degrees. Okay. And then to do that in the exact opposite direction, to convert radians to degrees, we take the radians that we're in, we multiply it by 180 degrees over pi radian. Okay, so it's no different than going from inches to feet, feet to yards to miles, etc. Right? The conversions work in the same capacity. except now we're going to use degrees and radians for our units as opposed to inches or feet or miles, etc. Okay, so let's do an example of this. So let's convert 4 pi over 3 radians to degrees. Okay. So I take 4 pi over 3, and since I'm in radians, times 180 degrees over pi radian. Okay. Well, as you can see, my pi radian disappears, right? They would divide out. So I really have 4 times 180 degrees divided by 3. Okay, plug this in the calculator or do the arithmetic, and you come out to having 240 degrees. Okay. All right, so now let's look at another example that I want you to try on your own first. So convert 60 degrees, write that a little better. Convert 60 degrees to radians. So go ahead and pause the video and try to solve this one on your own. Okay, so assuming that you paused the video and now you're going to work this out on your own, I'm just going to go over it. So I have my conversion of 60 degrees times, I have degree radians over 180 degrees. Okay. Well, here my units of degrees go away. So I have 60 pi radians over 180 radians, or excuse me, just over 180. Okay. And I don't know what this equals in my head. So this would be a time that you would just plug this into the calculator and you get 1.047 radians. Okay. All right. So now to just kind of continue along with the idea of converting degrees, let's introduce fractional degrees. Okay. So maybe it's not a whole degree. Okay. Well, fractional degrees are expressed in minutes and seconds. Okay. So you may, if you think about latitude and longitude, right? They'll say, okay, it was at 42 degrees, 11 minutes, and 29 seconds. Okay, so that is how degrees, when you don't have a whole degree, you can use minutes and seconds to signify that. Okay, so 1 with a single prime there, that is 1 minute. Okay. And similar to how you think of time, 1 minute is 1/60th of an hour, except here, instead of having hours, we have degrees. So a minute is a 60th of a degree. So then if you have 2 primes, so 1 double prime, that equals 1 second. That is equal to 1 over 3,600 of a degree, because there are 3,600 seconds in an hour. Okay, so it works the same way as regular time does, except instead of talking about hours, we're just talking about degrees. Okay, so let's do one here. So let's say, I think this would be example 3. So let's convert the angle measure to decimal degree form. So let's say that I give you 200 degrees, 24 minutes, and 12 seconds. Okay? Then I want to know what this is in a decimal form. Okay? So how I can do this is to say, well, this is 200 plus 24 over 60 plus 12 over 3,600. Okay? Because 24 minutes would be 24 over 60, and then 12 seconds would be 12 over 3,600. Plug it in the calculator, and you get that it's 200.403 degrees. Okay? So that would be an example of how to convert angle measures to decimal degree forms. Okay? Now, if the angle is negative, so it went in a clockwise direction, let's say that we have a negative angle of 110 degrees. Okay? And then let's say 18 seconds. Okay, so the thing that I want to show you with this being negative is that this angle lies between a negative 110 degrees and negative 111 degrees. Okay, so I don't want to add here because it's negative, so I'm going to say it's negative 110. So negative 110 degrees minus 18 over 3,600. Okay, since it still lies between, I want to make sure that this angle, when I figure it out, lies between negative 110 and negative 111. Okay. All right. So that being said, plug 18 over 3,600 in the calculator, and you get negative 110 degree 0.005 degrees. Okay. And so that is how you convert minutes and seconds into degrees, or into decimals for the degree form. Okay. And so the last thing that I want to talk about in this section is a couple applications to this. Okay. So the biggest application, we are talking about circles, so arc length. So being able to identify and find the arc length is an important concept, okay? So let's say that we have a circle with radius r. We have a central angle theta. And this central angle, so let's say theta intercepts an arc of length s. Then S is equal to R times theta. Okay. So let me just show you a picture of that, just because that's a lot to maybe take in. So we have a circle that has radius R. All right. Well then, let's say that we intercept here. That's also R. Here's our angle theta. Well, this portion is S. Okay. So what this allows me to do is, for our last example here, I think it's 4. Let's say that we have a radius of 6 and the central angle theta measures to 4 pi over 3 radians. Okay. Find the arc length. Okay. So we want to find the arc length. We want to find S. Okay. So S would be equal to 6 times 4 pi over 3. Plug that in the calculator. It does equal 8 pi. But if you plug it in the calculator, you would find that this circle that we're given would have an arc length of approximately 25.1 units. Okay, so the arc length of this circle would be 25.1. Okay, so that concludes section 4.1. If you do have any questions about any of it, please feel free to email me. But if not, have a great rest of your day.